Hi Dr. Chin, in this video, I'll be demonstrating the functionality of my game Galaxy Savior and highlighting some of the object-oriented programming concepts that I have integrated into the game. Let's start. In the first feature, let's take a look at the graphical user interface of Galaxy Savior. As you can see, the game starts with a captivating Galaxy theme main menu. The buttons for starting the game, accessing instructions, and quitting the game. Now, let's go ahead and click on how to play to see the instruction. So for how to play, I have implemented various graphics of the main element in the game and only use some simple words to describe overall game rules so that user can understand it more easily in an interactive way. Now back to main and start the game. As we move into the game, notice how the player's current status is displayed at the top left corner. This information includes the player level, health point, and the number of lights collected. As we move on to the second features, let's explore the player control mechanism in the Galaxy Savior. The player character is controlled using the WSD keys. Pressing W moves the character to upwards, A to left, S to down, and D to right. During the game, the spacebar can be used to pause and resume the game, providing players a break to think about the strategies and the next move. Next, let's take a closer look at how different game entities are generated and moved within the game world. As you can see, lights are scattered throughout the galaxy and remain static, while meteorites are spawned and moved in a straight line based on the player's initial position. Let's see if the player stays in the same position. The meteorites will move towards the direction of the player, so players should move away to avoid hitting by the meteorites. For every increasing of 5 levels, the boss will be generated. Now let's play until we reach level 5. Okay. So now we have reached level 5. And we can see that the boss is generated and the spawning of meteorites will be temporarily stopped. The boss moves in multi-direction. It follows the player movement, tracking them wherever they go, while health items are generated at the center and move in random directions. Moving on to the last feature, collision detection is a crucial aspect of Galaxy Savior. When a player collects a light, their collected light count increases. Colliding with a meteorite results in a decrease in health points, as I showed you before, and attack by boss will continuously reduce the health point by 1. So, while health items will replenish health by 5 points. And when the game health point reaches 0, the game is over, and the final score will be displayed. Player can click Q to back to main. Now player can either start a new game or quit the game entirely. As we conclude the demonstration, I would like to highlight some of the object-oriented programming concepts that I have integrated into Galaxy Savior. Classes and inheritance have been used to create a structured hierarchy of game entities. The abstract class game entity serves as a common class for shared attributes, while traits like moving is incorporated to any game entity that can move, such as player, boss, health, and meteorite, except light, because only the moving object can have moving speed, as you can see. And additionally, the utilization of parametric polymorphism through list buffer has also facilitated the flexible handling of collections and enhancing the game adaptability. So list buffer is used to store the group of game entity such as the light group, meteorite group, and boss group and health group. So in conclusion, Galaxy Savior is a result of integrating multiple object-oriented programming concepts to create an engaging and dynamic games. Thank you and have fun in playing the games.